Assalamualaikum and selamat sejahtera. Hi all. Our project is quite different than others, as we want to explore more in statistics subject and try something new. Hence, our study case will be chi-square statistic-goodness of fit test Poisson distribution. A population is the entire group that you want to draw a conclusion about, while a sample in the specific group that you will collect data from, the size of the sample is always less than the total size of the population. A good useful a good useful sample must not be biased. Member of the members of the sample are randomly selected by representative of the population. In order to get a good useful sample, several methods from Several methods for selecting sample have been proposed. For example, simple random sampling, cluster sampling, systematic sampling, stratified sampling, and the most common approach to produce a sample of the population to avoid bias is to select a simple random sampling method. If the size population is large, so it is easier to adopt alternative method which use random number tables or the random number facility on the calculator or computer. For example, in this assignment, we are set to the population of students in range 1 to 162 students and proceed to a sampling frame where they list all the 162 students with the number of the car accidents for 45 consecutive days. We use Excel program function to generate the 30 random student random sam, random student random sampling method used because each item in the population has an equal chance of being selected and the selection is always unbiased. Next, in order to find a critical value, we use the chi-square distribution table. So, first column of the table is number of degree of freedom V, and it ranges from 1 to 30 students. The first row of the table is the probability P, while the number inside the table are the value of critical value associate with probabilities given in the first row. The chi-square statistic can be used to test the hypothesis of the goodness fit or the independence of two variables. A chi-square a chi-square goodness of fit test is used to use it is used when we have some practical data and want to know how well a particular statistical distribution, such as binomial and normal models that the data. The null hypothesis H naught is the particular distribution thus provide a model of the data, and the alternative hypothesis is the is that it does not. To conduct a goodness of fit test, we must consider a certain assumption, which are the data are obtained from a random sample, and the sample data consists of frequency counts for each the different categories. In our case study, we claim that the number of students cars the number of student of cars accident per day is becoming worse. We are given a task to investigate the number of students car accident per day of 30 students randomly picked for 45 consecutive, consecutively. We are asked to collect data which consisted of 30 students with their number of accidents for 45 consecutive days. And we also calculate the mean and standard deviation from the data that we collected. Discuss the suitability of the Poisson model, then conduct a goodness fit of test to check whether car accidents per day follow Poisson distribution with unknown parameters which estimate the mean from a sample. Finally, provide comment on the result after carrying out the goodness fit the goodness of fit test for unknown parameters and its suitability.
Okay, so my part is going to be the methodology part, which is I'm going to take the 30 random sample out of the population, which is 162 by using Excel. This method is called a random sampling method, and the number that we are picked is not repetition, and we doing this using the 30 random sample because it is more complex to calculate the population by statistically. So after we get it, we're going to see to the part two, which is going to tabulate the data for the number of students that involved in car accident for zero is 8 days, and for one time it occurs it is 15 in a day, and for the number of students that occur in the two time is 14 days. For the number of students that involved in the car accident of three is 2 days, and for the four time it involved in the car accident is 1 day, and the same is for the five time the student get involved in the car accident is one, and for more than six it is 4 days. So for the number three, we are going to calculate the mean, which is we are using the x1 multiplied by f1 plus x2 multiplied by f2 plus x3 multiplied by f3 until it is xn multiplied by fn, and we are going to divide it by frequency. So we're going to get the answer, which is the summation of fx over summation of frequency. For the standard deviation, we are using the square root of the summation of fx square over summation of frequency minus a mean to the power of 2. So for the number four, we are going to check the case we are using is suitable for the Poisson distribution. It is under three criteria, which is one, it must a set of events that occur randomly in space or time. For number two, it is the event that occur independently. For number three, it is the event that occur at a constant rate. For number five, we are going to expect the null hypothesis, which is H naught. The data that support the assumption has the particular type of distribution, and it is follow up the case in the Poisson distribution. And for the alternate hypothesis H1, it is quite the opposite of the statement that we are stating is not. For the number six, we assume that the hash naught is true, and we calculate the Poisson probabilities by using the formula, which is exponent to the power of negative lambda times by lambda to the power of x over x factorial, and the x must be integer of 0, 1, 2, 3, and so on. So that's all for my part. Thank you.
Next, I will continue the methodology for step 7, where the expected frequency E are calculated by using the formula EI equal to sample size times probability. In our case, the sample size is 45, and the probability are calculated by using Poisson probabilities, which is for each x equal to 0, 1, 2, 3, and greater or equal to 6. If the original classes chosen lead to the expected frequency less than 5, then we combine the adjacent classes to form a class that is sufficiently large. Next, for step 8, we want to find the degree of freedom. So we have two cases where the lambda or the mean population are given. We are using the formula V equal to K minus 1. For our case, the parameter of the population is estimated. So we are using the uh, formula V equal to K minus M minus 1. M is usually equal to 1. For step 9, the significance, we fix the significant level of a test is the probability of rejecting H naught when it is in fact true. The critical value depends on the significance level and also whether the test accept or reject the null hypothesis. The critical region can be obtained by using chi-square distribution table. If the chi-square value are greater than the critical value, then we reject H naught. For example, in order to calculate critical value, if the degree of freedom is equal to 3, then the significant level of the test to 90%, then the critical value is 0.584. Next, for step 10, the chi-square statistic are calculated by using the formula chi-square equal to the summation of observed frequency minus expected frequency, and um, we uh, we square it, divided by and then divide by expected frequency. And lastly, if the value of the test fall in the critical region, then HO is rejected. So H1 is accepted. When the chi-square statistic value of a test statistic fall in the critical region, we have strong or sufficient evidence to reject H naught. When the chi-square statistic value of a test statistic does not fall in the critical region, then we do not have the sufficient evidence to reject H naught. That's all from me. Thank you.
Hi everyone, I will present the result and discussion. I will move to the result first. To have a big vision, I will zoom it to the result first. Here we can see that uh, I denoted X as a number of student car accidents per day, and I tabulate the data accordingly. And the first step, I calculate the mean, where summation of fx divided by the summation of frequencies, uh, and I have 1.8822. Next, I calculate standard deviation, where square root of summation fs squared divided by f minus b by x squared, and I got 1.664. To get the variance, I just square it, I get 2.769. Next, since the parameter lambda is an unknown, the sample mean is an unbiased estimate of the population mean. That is lambda equals to bar x equals to 1.822. A goodness of fit test will be carried out to the test the sample data by using Poisson distribution with lambda equals to 1.822 at 90% significant level. As I denoted X as number of students car accident per day, H naught will be the number of students car accident per day has a Poisson distribution with lambda equals to 1.822, while H1 or alternative age, the number of students car accident per day does not have a Poisson distribution with lambda equals to 1.882. We assume under age naught, uh, it follows the Poisson distribution with lambda equals to 1.822. We calculate the probability of Poisson distribution, and the probability of Poisson for 0, s equals 0 is 0.1526, while 1, 0.2780, and so on. Then we calculate EI. EI equals to observed frequency multiply multiply with the probability. And total observed frequency is 45 divided by probability, and we got 6.8670 for x equals 0, while x equals to 1, 12.5100, and so on. Next, uh, next, in the second slide, we can see that there are three expected frequency fall below 5. The value was combined with the adjacent value together, and the following result shown in the result. As we can see above, that with x equals to 6, 5, and 4, the I value is less than 5. So what we do is we combine it together and make sure it is greater than 5. Next, we calculate the degree of freedom. Since the parameter lambda is estimated, and this is case 2, then we use the formula V equals to K minus 1 equals to 3. Then at 90% significant level with the degree of freedom 3, the critical value is 0.584. The critical value was obtained by using the chi-square distribution table. Then the condition where if the chi-square statistic is greater than 0.584, we reject H0. The following table is a form to calculate the value of chi-square statistic. And as we know, the formula is summation of observed frequency minus estimated frequency. We square it divided by estimated frequency, and we calculate for all the x values, and we have 5.2360. We sum up all, and the claim, or the final part, where we can see that 5.2360 is greater than 0.584. Thus, it falls in the critical region. At 90% significant level, we do have sufficient evidence to reject H0, and we conclude that the number of students car accident per day does not follow Poisson distribution with mean lambda equals to 1.822. Then I move to the discussion. For the discussion, we can see that from our observation, the data I collected does not follow Poisson distribution. From our calculation, the sample mean was 1.822. Variance is 2.768, while standard deviation is 1.664. The requirement of data to follow the Poisson distribution, variance of a Poisson random variable, is equal to lambda. Since the variance of the number of students car accident per day is almost 2 times estimate lambda, then we can say that the data does not follow the Poisson distribution. Next, we encounter situation where the rate of accident may not be constant. The rate of car accident may not be constant over the 45 days period. It was like fluctuating due to the various factors that affected. For example, maybe the condition weather, time of day, or changes of traffic pattern. I will take some example where there were heavy rains and flood in the Pago and Mua area can causes accidents. Another example, if parking is limited in college, students who double park their car easily get into accidents. So the data that I collected was less accurate, plus the students who illegally bring their car without having proper driving license, training, and less experience causes accidents too. So this might be one of the factors why the data does not follow the Poisson distribution. In other hand, from our observation, the number of students car accident per day are actually dependent on the situation of the students. But for the Poisson to assume that the data is follow the Poisson distribution, the events are independent of each other. However, in this case, students car accident, there are many certain factors that increase like the likelihood of an accident occurring. For example, if a student has had a previous accident, they may they may be not likely to have another accident in the future. This means that the number of accidents one day may be dependent on the number of accidents on previous day, which will violate the independence assumption of the Poisson distribution. Similarly, students who get in accident are more preferable to use buses arranged by the university to go to campus or student grad as they are very safe for them and it's very cheaper too. So these factors are likely to cause the number of students car accident to vary over time and not follow a Poisson distribution. So I can conclude that for a Poisson distribution, the evil occur independently, but they are not actually. Next, we look at the significant level of bonus fit test where we fix to the 90% because to avoid type 2 error, where accept the false null hypothesis, where H0 is accepted and H1 is rejected, yet in reality is not true. In order to prevent this, as far as possible, any false claim from happening, the significant level is fixed to 90%. However, the higher a significant level is the most tolerant of a type of error exists and more likely where to reject the null hypothesis by mistake. But nothing to worry because not all cases of type 1 error will exist. Since in our case, it doesn't follow the Poisson distribution from the observation we have proven just now. Finally, the critical value obtained by using the chi-square distribution table actually depended on the degree of freedom and significant level. Normally, if the population parameter lambda is given, we use formula uh, lambda is given. If the population parameter lambda is given, uh, we will calculate the uh, Poisson probability. Unless if they doesn't provide, then we use the formula bar x to calculate estimate mean. Some sample statistic parameter lambda need to be computed by estimating, as I said just now. For example, at 90% significant level, 5 categories with parameter lambda are estimated. Degree of freedom and the critical value will be 0.584. I repeat again, here we use case 2 to find the degree of freedom, where since we are estimating the bar x, we use v equals to k minus m minus 1. Since we estimated one parameter, then we minus with 1. However, at the same significant level, with 5 categories with population parameter lambda is given, degree of freedom and the critical value will be 1.064. This implies that the critical value dependent on the degree of freedom. Although the claim is true, we state that the student's car accident is becoming worse, but the distribution cannot be modeled by the Poisson distribution. Next, I move to the simple linear regression method where I generated from using Excel. A simple linear regression is statistically technique used to find relationship between variable and predict future values. Uh, as we can see, the regression statistic, the correlation of coefficient known as a multiple R, how strongly two variables are correlated linearly. It is absolute value, which ranges from -1 to 1, and then the R square coefficient of determination is a measure of fit quality in range from 0 to 1, with a value around 1 suggesting the model fit the data well. For instance, the X value account for 0.46 or 46% of the y-axis, while standard error depicts the precision regression analysis, and the value is on the regression statistic table. Next, B naught is 12.107 and B1 equals to negative 1.893. Hence, we get the equation where y equals to negative 1.893x plus 12.107 will be our regression equation. And that's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and very good evening. My name is Ahmad Musakim. I will be presenting the conclusion of our project. For our claim of our project, the data collected for a number of students' car accidents per day does not follow a Poisson distribution and is considered satisfactory. A strong linear relationship between the variables used in a linear regression model is indicated by a correlation coefficient, multiple R of 0.46. The model fits the data well with the R-squared coefficient of determination of 0.46 or 46%. The regression equation achieved is y equals to negative 1.893x plus 12.107, where the coefficients are beta naught of equals to 12.107 and beta 1 equals to negative 1.893. Goodness of fit test is fixed at 90% to avoid type 2 error. The critical value obtained by using the chi-square distribution table also depends on the degree of freedom, parameter lambda, and significance level. That is all from our team. Thank you very much. Assalamualaikum.